Now let's talk about the Q value. What Q value is? Q value is a total rewards an agent can expect to receive from a state. So let's take an example here. We have the agent here, which is on the state S2, and it has only two possible actions, to go on the left or to go on the right. If it goes to the left, it will receive first a reward of +1. And here, the best solution is not to continue to go on the left, because the next reward will be -1, and the total reward will be +1 minus 1 is equal to 0. So the best solution when you are on state S1 is to return to S2. So the total reward you can expect from the state S2 with the action go to the left is +1, only +1. So this is the Q value of S2, the action go to the left being in the state S2. Now, being in the state S2, you have the opportunity, another choice is to go to the right. So if you go to the right, you will receive first a reward of -1. But if you continue to go to the right, you will receive another reward of +5. So the total reward is -1 plus 5, it's +4. So +4 is the Q value of the state S2 of the action go to the right being on the state S2. Okay, so we will see on the next slide that this Q value will help us to decide which action is the best one to choose for an agent. Okay, so in reality, we don't really do the sum of all the reward, because the future rewards are uncertain. So it means that for the next reward, we are sure to get +1 or -1, but for the state in the future, we are not completely sure to get this value because of uncertainty. So to take into account this uncertainty, we will apply a discount to the total reward. The discount is a gamma factor. Gamma is a number between 0 and 1, more close to 1. And the total discounted reward is equal to the next reward, here, for example, -1. And the next reward, +5, is discounted by this factor gamma. So it's not really +5, but it's +5 multiplied by something like 0.9, for example. So this is the formula to compute the total discounted reward using the gamma factor. So the policy is a function that returns the next action based on the state observations. So you are the agent is on a specific state. We have some observation, and we give this to the policy, and the policy returns the best action. The best one is the one which allows us to have the highest expected reward. So how will we manipulate this Q value? We will use what we call a Q table. If the number of actions and the number of states for the simulation is small, then we can use a Q table. A Q table is something like this. Okay, so you have here the states. For example, for this game, we have only 3 states: S1, S2, and S3. And for each state, we have only 3 possible actions: A1, A2, A3. And here, in this Q table, each cells of this table contains a Q value. So, for example, imagine we are on the current state is S2. When you are on S2, you have the choice to perform the action A1, A2, or A3. And here is the Q value for each of these actions. And the policy, given a state, is to choose the action with the highest Q value. So here we will choose the action A1 because it's the one which has the highest Q value. So the next time we will perform A1 on maybe, for example, A1 drive the agent to a new state, the state, for example, S3. So now we are on S3. We have the choice between A1, A2, and A3, but the policy say that you must choose the action which gives you which has the maximum Q value. So we will choose this action. We will choose the A3 and so on. So with a Q table, if we are able to compute the Q table for a specific problem, with a policy which consists in choosing at each time for each state the highest Q value, we have a process to choose what is the next action to choose to get at the end the maximum expected reward. So to compute the Q value, we will use the Bellman equation. So here, this is the updated Q value for the state S on action A, and it depends. This new value depends on the previous, and is calculated by this formula. So I will try to explain with this schema here. So imagine that you are on the state S and you have different actions. So you can choose action A, another action A1, A2, and A3, and so on. So if you choose the action A, you will receive a reward, the immediate reward, from choosing the action A being on the state S. On this, doing this, your next state will be S prime. So this value, this R, is the reward from choosing the action A from state S and going to the next state S prime. So you are on state S prime, and when you will be on state S prime, you have the choice between different actions too. And here, each of these actions has from state S prime has a pre-computed Q value. Okay, and here when you will be here, you will choose the highest Q value, the action corresponding to the highest Q value. So this is what the Bellman equation says. Bellman says that the Q value of this action, the action A, being in the state S, is the immediate reward that you will get from choosing the action A. Okay, and now, because you are on state S prime, you will choose the maximum Q value here, and you will later choose the action A, which gives you the highest Q value, the highest next Q value, and you discount this with gamma factor. Okay, so now we will do Q learning. Q learning consists in learning the Q table, the value of the Q table, by repeating playing actions. We play actions on the environment, and each actions allows you to update the value with the Bellman equation. So this is what we have here. This is the general update equation using the Bellman equation. So this is the current Q value of action A being on the state S. And with this current value, we will update this current value with this formula, okay? And it gives you the new Q value of action A being on the state S. And by repeating, choosing different actions and playing these actions on the environment and getting information from environment and applying the Bellman equation, we will update regularly the Q value of action A being on the state S. And this Q value will, at the beginning, they are randomly chosen, but doing this by repeating this iterative process, this value will converge to the good values of the right value of the Q table. Okay, let's see this on an example. For example, here we have a Q table here. You have actions here. It's inverted. Here we have actions on the row, and we have state on the column. So this is this little game. The goal is to, for the system, is for the agent, is to try to find the policy to send the car on this goal, on the top right cell. So this is the current cell. Current cell means 0 means 1 means the car is here. So the car is on the middle cell on the bottom. So here. On every else, there's no cars. Okay, so this is the state, this state. So just you can realize there's only 6 states for this game. The car can be here, 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 and so on. And for each state, we can only perform 4 actions. We can go up, right, left, or bottom. And here is the Q table at a certain instant. Okay, imagine we start from random values for the Q table, and we iterate the process of choosing an action and updating the Q table, the cell of the Q table with the Bellman equation. And now we are in this state, and we have this Q table. Okay, so when you are on this Q table for this state, the first thing to do is to select which action to perform. To do this, we look at all the Q values here, 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 and here, and we select the action which has the highest Q value. So the highest Q value is here. So the next action will be go to the right. So this is the action. If we perform this action, the car will move from here to here. Because the car doesn't reach the goal, the reward associated with the action going to the right from this state, the reward is 0. Okay? On the next state will be this one, because the car will be here on the bottom right. Okay? So, because the car will be here, we have to look at this column now, because this is a S prime state. On here, the maximum Q value is this one. So if we apply here the previous equation, we do this with a learning rate of 1. So this value equals 1. So this one and this one cancel. We just have this on this. We just have this part. of the equation. So R, the reward is 0, okay? Gamma, we choose gamma as minus 0.95. On the max Q value for the next state, for S prime, the max Q value is this value here. So it's 1. So if we compute everything, it's 0.95. And this is the new value for the QSA. So the QSA was before 0.4, but it will be updated by 0.95. And now, because the car is here, and we have to, so here, we are here, and we will choose which action is the best one. No, excuse me. The new state is this one, and here we will choose which action is the best one. The one which has the highest Q value is this one. So the next action will be to go up. So going up, the car will reach the goal. Okay, so by repeating all this process, you will update the different Q value of the Q table. So now we are going to see the algorithm which is used to do the Q learning. Q learning is to learn the Q value of the Q table with the help of the Bellman equations. So we first defined 3 values, 3 constants. The epsilon is the value used by the epsilon greedy strategy to choose between exploration and exploitation. The alpha is here. Alpha is learning rate. And gamma, which is here, gamma is a discount factor. It's a value close to 1, but less than 1. Then we define a Q table. So a Q table has actions as row and state as column. And we put a 0 for each initial value in this Q table. And we start with the state S. And we get information, we observe the initial state S. Then we will repeat until we decide to stop. So we decide, for example, we can decide to stop, to terminate this algorithm if the update, here is the update parts. That's what we will add or subtract to the current Q value to compute the next Q value. If this is lower than a certain value, certain threshold, we decide that we will stop this algorithm. So first we have to select an action A from state S. So for this we will use the epsilon greedy strategy, and depending on the random value, and compare it with epsilon. With a probability of epsilon, we select a random action A. So this is exploration. But with a probability of 1 minus epsilon, we choose the best action, the action which has the highest Q value. So this is exploitation. So we perform the action A. Okay, we carry out this action A. So doing this, it will change the state. We will be now in the state S prime. From state S, performing the action A, we will be on state S prime and receive a reward of R. So now we have all the information to be able to compute, to update the Q value. So we first compute this here. So we have the reward here. We have the gamma, which was defined here. We get the maximum Q value from state S prime. So we have to check for all the possible action from state S prime, which one has the highest Q value, and this will be the values that we will select here. So we have computed all this. Now we save this on the Q target. So the Q target, which is this value here, we subtract the current Q value of action A being on the state S. Action A being on the state S. So we compute all this here, and all this is a Q delta. And Q delta multiplied by alpha here, and all this value Q delta multiplied by alpha is added to the current Q value QSA, and it's the new value of QSA. And of course, the new state is the state that we reach after performing the action A, so the state S prime. And then we continue like this.